structure. So this is product structure that I have here. I'll Prota details. So while it is opening, let's take a look at some theoretical facts about product structure. Product structure, like I said earlier, is actually a structural design software. There are a lot of other structural design software, but the one we use mostly in this part of the world is product structure, right? Um, it is actually an advanced form of Orion, right? Orion has been there for a long time. So I think product structure bought Orion company. I'm not sure, but I think so. So product structure is the modern one that we are using now because it has the capacity is much, the features are much, and it is easier to use, right? So some basics of product structure is actually that it was designed by a UK-based company, CSC, and it is meant for analysis and design of stock concrete structures, right? It also has 2D and 3D modeling environment. So just like Revit, in product structure, you can actually make your modeling in 2D and you're also going to see it in 3D. But the difference now is that in structural design, what you are modeling is just the skeleton of the structure. And what I mean by the skeleton of the structure is the structural members, like your beams, your columns, your slabs, your foundation, right? These are the main structural elements. Other structural elements are there, could be your retaining wall, if you have maybe your shear wall, maybe for lifts, if you have a lift in your structure, and your culverts. These are all non secondary structural members, right? But the primary structural members is your beam, column, slab, and foundation. So product structure allows you to model them in 2D and 3D as well. Product structure is perfect for any size of concrete structure. You can use product structure to design structures as high as 40 stories, 50 stories, as the case may be. So it caters for a wide range of structural elements. And it can also design even non-structural members. Like I mentioned, your retaining wall, your culvert, your water tank, concrete water tank, your dams, a lot of non-building structural members also can be designed with Protastructure. Now, many people actually think Protastructure is actually, of course, Protastructure is technical in the sense that you use it to produce technical drawings. Structural drawings are simply also called technical drawings, right? Your beam drawing, column drawing, foundation drawings, like these are all technical drawings. But then product structure makes it very, very easy, even for beginners to use, in the sense that it in product structure you can impute details and it will give you output. Now, if the values you imputed are not correct, probably the values you imputed have issues. Product structure can detect failures, right? Take for example, I'm designing a two-story building, and I imputed that product structure should use 12 bars to design my columns. Now, if after analysis, 12 bars is not sufficient for the columns, product structure is going to mark those columns as failed. It is not going to give you the output, right? So it makes you confident that whatever result the software is giving to you is at least 90% accurate, right? Do you get? So it makes it beginner friendly. So you can impute values into the software and it will give you output. Now, this is also kind of there's something else to it, because you need to understand the basics for you to be able to impute correct values. Basics such as the code that you're supposed to be using, the reinforcement that you're supposed to be using, the the size of members that you're supposed to be using. Say, for example, the size of your block work or the size of your column or whatever. So you are supposed to have those fundamental knowledge for you to be able to impute correct values into the software. And also the type of loading that you're supposed to be doing in the structure. Right? Let me just branch into, because loading is a very important factor in structural design as well. If your loading has issues, your structure is going to have issues. So Fundamentally, we have two types of load. We have the dead load, we have the live load. Dead load simply means the load of the structure itself. And take for example, you consider yourself, consider your weight, like you're a human being, right? So your weight is your dead load. You might be weighing maybe 100 kg or 50 or 70 kg or thereabout. So that weight is called your dead load. It is simply because you cannot take it away from you. Like it is your load, it is what you weigh. So in like manner, the dead load of the structure is the weight of the structure itself. So you have to consider the dead load of the structure. Now, you also have to consider the life load of the structure. The life load of the structure is simply the load of any other thing that is on the structure. Say, for example, if you are holding anything on your hands, that thing is termed as a life load because you can drop it at any time. So, in like manner, in the structure, the weight of the furniture, the weight of the people, if you're designing a church or you're designing a mosque or you're designing a mall or a shopping mall, the weight of the people coming in and going out are also known as life load. So there are different values for life load. You have to have knowledge of those fundamentals. Now, secondarily, you also have wind load. If you are designing structures above 10 meters in height, you have to consider wind load because the higher your structure goes, the more critical the wind load acting on it becomes, right? So you have to consider wind load. So Protastructure actually allows you to consider all those loading. Now, if you are designing maybe a dam, then you have to consider the water current load. If you are designing a bridge, of course, you have to consider that. If you are designing a retaining wall, you have to consider earth load. If you are designing, now also depending on the environment where your structure is going to be built. If you are designing a structure in the West, maybe in the US, in UK, where consider what they call temperature load because there is unevenness in the temperature. At some point of the year, it's going to be very cold, up to minus 30, the strength of concrete. So you have to take note of what we call temperature load. So there are various types of loads that we consider. Fundamentally, where we are in Africa, we basically consider dead load, live load, and consider wind load, right? So the fundamentals are part of what we are going to be doing in the course of the boot camp. Now, the like of this of your modeling, and you can also have the 3D parts. Let's quickly take a look at how the software works, the Protastructure software. I'm going to open my screen so that I can show you a sample drawing, right? A sample drawing. So this is my Protastructure software right here. So if you install Protastructure newly, you are going to see this place is going to be empty because you might not have done any project. So you can see these are recent projects. So the last 3 projects or the last, I don't even remember, the last project you do will be shown here, right? Here you can open an existing project. Here you can click on a new project, right? So here, if Protastructure has some news, they are going to be shown here. Like you can see, was a fair that was organized in Ghana, I think in January, right? In January, a fair was actually organized by Protastructure. I think they were kind of doing some marketing in Ghana. So you also have some videos here that are going to be shown to you, and you have some notifications right here as well. So I'm just going to open a previous project to show you what is possible. So this project actually was how it. So this project was actually made with was one of the projects that we did in the last boot camp that we had on Protastructure. Let me open it. So likewise, in the course of the bootcamp, we are going to be doing 2 projects in Protastructure as well. We are going to be designing a bungalow as well, and a bungalow on pad foundation, right? We are going to be designing a bungalow that is on pad foundation, and then we are going to be designing a duplex that is on raft foundation as well as on, because we want to cover as much as possible in the course of the bootcamp. So you can see this particular project is on raft foundation. You can see the raft beams. The raft beams are 1.2 meters in depth, and the raft slab is about 250 millimeters in depth, right? So this is your raft, and then you have your regular beams, the first floor beams that you have here, which is 450 thickness, 450 depth, and 225. We're using 9 inches block work, so that is why the breadth of our beam was 225. And our columns was also 225 by 225. And then our roof beams, we reduce the roof beam to 400 in depth, right? So we also applied the roof load on the roof beams. You can see the roof load here, and also have the wall load on the floor beams. Then you can see an arc. This was a balcony, an arc balcony. So you can see how we created a curved beam as well. Why this is a cantilever slab, you can see here. They have a cantilever slab. You just have beams on 2 sides, right? So this is how you model your structure. This is the 3D. Like I said earlier, you can see the 3D, but what the 3D you see is just the skeleton, and the skeleton are the structural members. That's beam, column, slab, and foundation. Then you can see the plan view right here. This is the plan view. So you can see the slabs respectively. This is where we have the staircase. That is why it is open. And this is where we have the exits, right? So we have the staircase here, and we have the exit here. So this is the living room for the structure. You can see you have a very big slab here, right? So, and then you have this slab. The slabs are simply 150 mm in depth. You can see here, 150 mm in depth. Now, these lines you see here, they are called yield lines. Let me quickly explain what they mean. Now, you know that if you are designing a structure, like I said earlier, the loading is the most critical part of structural design. You have to get your loading right. The loading simply is transferred from the roof to the roof beams, from the roof beams to the columns, from the columns to the foundation, right? So it is actually a complicated process. If you go to 3D, so you can see I have my roof here. So my roofing load is transferred to the roof beams. The roof beams is transferred to these first floor columns, and then the load is transferred down to these ground floor columns. Now the ground floor columns is also bearing the load of the slab, which is the first floor slab, bearing the load of the roof of the floor slab, the first floor beams, and then it is all going down to these columns. And then the load is all together now going to the foundation, right? And then the load is all together going to the soil. So this is how the loading is transferred. So if you look at this yield line simply tells us how the load is transferred. You can see this triangular part, the load is going to the beam. This trapezoidal part, the load is going to this beam. This trapezoidal part, the load is going to this beam, and this one is going to this beam. So this beam is simply carrying the load of this trapezoidal part and this trapezoidal part together, and they are all transferred to the beam. Now, in addition to the dead load of the beam, the load is divided into 2 and transferred to this column and to this column. Right? Now, the same thing applies to this one. So this is the load of this part is going to this beam. This one is going to this beam. This one is going to this beam. So you can see it is all a complicated process. So you will notice that this particular column is carrying the load of this part, this part, this part, this part, this part. It is carrying parts of each of them, and it is going down. So that is why you will notice that the load from inner columns are usually higher than the load from external columns, because that of external columns is just carrying the load of few parts, while internal columns is carrying much on it, right? I'm going to explain some basic fundamentals as to how this loading is transferred and how you ensure that your structure is safe at the end of the day. It is very important, right? So now, if you have a pad foundation, definitely it is going to be different. So you have your pad in under each column, right? So the loading is going from the column down to the pad foundation and then down to the soil, right? So I'm also going to explain why and when you should be using pad foundation for your structure, why and when you should be using raft, whether it is beam slab raft or whether it is slab raft, or why and when you should be using pile foundation for your structure. These all have fundamental principles as to their usage, right? So I don't want to go much into details about that. So these are all the things we are going to be seeing in the course of this bootcamp. Now, additionally, there are 4 stages of structural design. You have your modeling, which is what you are seeing right now. Then you have your analysis. This is simply where you go to run your analysis. You can see it's a building analysis. Now, you also have your design, right? And then you have your detailing. Now, modeling, analysis, design is just about 30 to 40% of the work. The major work is in your detailing, because that is where people are going to see. That is where you are going to present your structure, your drawings in the detailing part. So detailing basically has principles as well, right? If you are detailing a beam, you should be showing the lapping, you should be showing, of course, the bottom and top reinforcements, you should be showing the sections, you should be showing other details as well. So the details that Protastructure is going to give to you may not be according to what you are looking for. So there is a detailing template that I'm going to be showing us in the course of this bootcamp, where you just have to import your structural drawings from Protastructure into that detailing template, and it is going to automatically edit the detailing for you, right? I would have opened AutoCAD, but I don't want, because of much time. So that detailing template is in an AutoCAD file, right? So you just import your structural drawings into that template, and it is going to make the changes. So the editing you are going to do is now going to be minimal, right? Of course, by the time you import, some people actually design with Protastructure and then they do the detailing from scratch in AutoCAD, right? But you might not want to go through that stress. You can do it if you wish, but then there's a template that you can use to make your work easier and faster in terms of detailing, because detailing can take you a lot of time if you are doing it from scratch, right? But with the templates, it's going to take you less. Right? So in Protastructure, you can see you have your modeling here. This is where you model the beams, the columns, the slabs, the rib slab, and all your members. Then you have your loading. This is where you apply your load, your dead load, live load, your load combination as well, according to British code. Remember, we are using British code for our design. Most design companies in Africa actually uses either the British code or the Euro code, right? But I don't think there's any much difference between them. There are other codes. You have the Indian code, you have the American code, you have the Japanese code, a lot of other codes, but we are using British code. So according to British code, Protastructure is going to generate the loading combinations and use the maximum load combination to make the analysis for you, right? So here you can review your model, you can do building model check, you can label your members, you can see the design status. Of course, you can see the design status is showing here. If anything has failed, it will show red, right? If it is yellow, it simply means warning. If it is orange color, it simply means that that analysis has been expired. If it is green, it simply means that the design is okay, which is what you have here. If it is white, it simply means it has not been designed. You can see our slab has not been designed. That is why it is showing white, right? White blue simply means do not design, right? So you can see the design status from here. You can apply loads, like I said earlier, beam wall load. You can apply slab additional loads. If you have any additional load, let's say for example, you're designing a factory that is going to have a lot of machines on the slab, then you want to apply additional load to take care of these components. Now you can also apply wall live load, right? Now you can go to analysis. Like I said earlier, if you go to analysis, you can actually input the reinforcement details that you want to be used for your structure, right? So if I click on building analysis, I can actually edit the materials I want to be used. The concrete grade. Concrete grade simply means the compressive strength of concrete. So you have a lot of concrete grades. You have, depending on the concrete mixture. Also, I'll be talking about this in the course of the bootcamp. The different mixture that actually gives you the different concrete grades. You have C5, you have C10, you have C15, you have C20. So there are different concrete grades according to the concrete mixtures, right? Okay, take for example T5. Simply the 5 simply means the compressive strength of concrete millimeters squared, right? So see, to get a concrete grade of C5, you need to use a concrete mixture of, I think, 1:2:4. 1 simply means the quantity of cement, 2 simply means the quantity of sand, and 4 simply means the quantity of the granite. So it means if you are using 1 kg of cement, you need to mix it with 2 kg of sand and mix it with 4 kg of granite in order to be able to get a concrete that has 5 Newton per millimeter squared as the compressive strength. So there are a lot more to that. So the same thing with steel. Steel also has its own concrete grade. Sorry, steel also has its own grades rather. So if you are into if you are into construction, you must know what we call the tiger rods, right? Tiger rods are simply the imported rods that we normally use. The tensile strength of that rod is 410. That is why we use 410 here, right? The not the local one. I'm talking of the imported rod, tiger rod. Yeah, the compressive strength is usually 410 Newton per millimeter square. So that is the one we use for construction and design as well, right? So that is what we are going to be using in the course of this training. So likewise for concrete columns, we can choose the diameter of bars we want to use. So you can see we have Y6, Y7, Y8, we have a lot of them up to Y50. So you can see for my columns, I only use Y16, right? For my beams, concrete beams, I used Y12 and Y16, right? For my slab, I only use Y12. And for my links or my stirrups, I only use Y10, right? Some people use Y8 for stirrups as you said. You can use any of them. So for foundation as well, you can set the diameter of bars you want to use as well. And then after that, you are going to run the analysis. This is where you run the analysis. And if anything fails, it's going to mark it as red. If it passes, it's going to mark it as green. So if it fails, it is now your duty to go back to your modeling to look at the reason why it failed and to make the necessary corrections. So we are going to be talking about all this in the course of this boot camp, right? So a lot to learn, right? So we have product structure starting from next Tuesday, Thursdays, and Saturdays, and we have Revit starting from next week, Monday, Wednesdays, and Fridays. So if you have any questions regarding product structure, you can let me know. I think we have come to the end of today's session. So if there are any questions, you can simply unmute your mic and let me know so that you can tackle it. I believe all the objections have been taken care of. The time factor as well as the time factor, meaning that we're going to be starting the boot camp by 8 p.m. every day. And then we also have the financial factor. We have 1 week from now to prepare. And of course, the prices are listed on the group for now because they are going to be increasing. They are going to be increasing. I don't know when, but so we take advantage of it while the time lasts. If you have any questions, you can also ask it on the group as well. If there are no questions, we can call it a night. And I'm going to see you next week, hopefully. For those of us that now, I forgot to mention the softwares are also included in the courses, right? The Protastructure software and the Revit software. So I'm going to be sending them to your email so that you can download them and then we proceed with the installation. Maybe on a video call, or I'll send you the video installation guide if you can follow it to install. If not, we're going to run a video call to do the installation on your laptop before the class commences. Because once the class commences, I'll not have the time to be doing installation anymore. So before the class commences, you need to get the software installed on your laptop. So if there are no questions, okay, let me allow 2 minutes for any questions. If there are no questions, you can call it a night. Yeah, Mr. Chooks, thank you very much for your time. Thank you very much for your time. So if there are no questions, we'll call it a night. And I'll see you next week. Thank you very much. Okay, you missed the Revit class. I am going to post the recorded version maybe in 1 hour time on the group. Yeah, it's all right. Thank you. So take care and good night.